Hello friends, welcome back to my channel. Today we are going to identify the structure using 1H NMR. So this is a given set of a data where we have given the 1H NMR and we have to identify the structure, which one is the correct one from A, B and C. So let us start the video. From given set of a compound we have the we have the 4 peak or 3 peak in aromatic region. This one is a peak at what you call as 5.74 singlet. Then we have total 3 peaks in aliphatic region of 2 proton, 2 proton and 6 proton. So these 6 proton clearly indicate those are of this dimethyl peak. So in this video I will try to tell you how to interpret the given 1H NMR. So let us look on the signal for the proton in aromatic region. When you zoom in this video, you will find that the proton at 6.38, wait a minute, the proton at 6.38 is a doublet and it's for one proton having coupling constant 8.6 hertz. So this proton has coupling constant of 8.6 hertz. Okay. The another one is the 6.95, which is doublet of doublet having two coupling constant, those of 8.6 and 2.4 hertz. So it has two coupling constant, that is 8.6 and 2.4, and the peak at 7.01 is of doublet having J value of 2.4. So with the help of this coupling constant, we can easily identify that the peak at 6.3 is split into doublet, so it has one nearby proton that is ortho to it. So 6.38 will have one ortho proton, whereas 6.95 will have ortho as well as meta proton. So 2.4 hertz is a coupling constant for meta substitution. So this peak will have ortho as well as meta. And the peak at 7.01 is having 2.4 hertz, the coupling constant, so that is for meta. So these 3 protons clearly indicate, so we have a substitution like this. Okay, we will have one proton over here, it will have ortho, and this will have meta. So we will have a ortho coupling with these 2 proton. This will have ortho coupling with this proton, and this will also have an ortho coupling with this proton. Similarly, the proton here will have also meta coupling with this. So this indicate we have this kind of a substitution in a given compound. So looking at the given structure, the A has a similar substitution pattern, 2 ortho and 1 meta. B also has 1 meta and 2 ortho, whereas in C we have all the 3 proton in equal range. So this could not be our answer. So the answer would be between A and B. Now look up in the aliphatic region. So it has 6 proton for dimethyl. So these both has the dimethyl group over here. They have 2 CH2. This one is first one and this one is another CH2. Both are split into triplet, indicating that we have CH2, CH2 substitution. So now we have to identify this CH2 and this CH2 is attached to nitrogen, or these CH2 are attached to aromatic ring, and we have NN dimethyl substitution attached to nitrogen. So considering the probability for the B compound, this nitrogen will have CH2 over here. So this nitrogen proton will be split into having 2 CH3, it must split into triplet. Looking the value of this chemical shift value of the proton of nitrogen, it's around 5.74 and it's for singlet. So if we have this kind of a substitution, so we should have nitrogen split into triplet. It will coupled with the neighboring CH2. So B is not the correct one. Now the answer would be A. Similarly, we can elaborate that when we have this kind of a CH2 substitution, one is attached to aromatic ring and another is attached to the carbon, will lie upon 2.5 and 1.5 delta ppm. When this CH2 is attached to nitrogen, it will be have more deshielded and it should come around the 3.3 delta ppm. So the correct answer is option A. Thank you guys. Hope you like my video.